through the noughties, really. I came through, I did design futures at Goldsmiths, then wanted to pursue a PhD, which really wanted to address the questions of how architecture wants to think about the digital, and whatever we mean by that. You have to imagine at the end of the 20th century, we moved through a whole bunch of changes as we adopted through Castells, the concept of the network society, and then more recently through the noughties, the impact of social media that I think constructed what we might call architectures, certainly architectures where people find some form of psychological shelter. If it isn't shelter from the rain, certainly people didn't delete Facebook when Cambridge Analytica represented the threat. So I do think architecture has to think very carefully about what we're talking about when we're talking about network cultures and the architectures of those, and then of course perhaps the economies that underpin those architectures. If we talk about the network society and place being partly constituted by our identification with social networks, Facebook through Twitter, through Snapchat, TikTok, whatever my kids are doing, the things in which they identify themselves have got to be questions for architecture. It's where they find themselves, it's identity, they're social, but they're also economic, and they're also material if we think about data as material. So today's little talk is really about how we've had to develop a language which design didn't give itself. We didn't take the time as we move through network culture into designing with data to actually decide what the words mean. Some of my colleagues at Edinburgh perceive data alongside wood, metals, ceramics and plastics, and they see it as a material which is outside of them that they can machine. Other people, theorists, tend to think that we're within data and that you can't, and we're entangled in it in a kind of Baradian sense, that it's impossible to get outside of data. And that might be because we're always producing data, but it's also because the economies that move data are also managing and providing what we call informatics, the flow, the study of the flow of data. And if I'm caught up in those economics and informatics, then it's very hard to escape it. So we then came up with this, the Ablative framework, but I'll unpack that a little bit. Just for further context, I lead a big lab. It's an institute now, and we have centres, sub-centres in health, blockchain, concepts of design by security by design, and even more conceptual abstract ideas of what it does mean to be a designer across the space of informatics. So it's a highly social, material, technical, working with the members of the School of Informatics, very high-powered computing people, working in AI, machine learning, deep learning, natural language processing, all these pieces of jargon, but try to suggest that designers are working alongside these computer scientists. And you can see from the network, or the people within the lab actually, they're all connected. I do like to keep social scientists close in the group, and we like to keep makers close in the group. So you've got this constant tension between those who design and push forward, and I do think architects have a positivist tendency. You do like to bring things into the world, but we certainly like to make sure that designers are riding side saddle with a social scientist, because the ethics of what you're getting involved in is too hot to not take deep care about. So we try to keep those things close, and then we also have very good developers, technicians who can build things. It's really important that we as a generation start making and turning ideas into physical, I should say experiences, not necessarily physical, because software might not be physical. But on to the idea of today then. So as I said, a few years ago, a colleague and I began to think about what are the words that would be appropriate to help a community of designers think about how they work alongside data. And John happened to be a scholar of language and philosophy, and was very keen to recover the Ablative framework. Now, the Ablative framework is from Latin, and it describes words that help us understand our relationship with something else. Let's have a think. So from, well, actually they did it by, so they always reversed it in the Ablative. So by, I might be by the lamppost. I might be beside something. I might be by something. And then the with, I might be with, and it might be part of a closer relationship. And then from, it might be somewhere I'm coming from or something I'm coming from. We flipped it because we think the ablative framework is just the beginning. It's just the beginning of a lexicon that allows us to think about how we're working alongside data. So very quickly, design from data. When systems are designed by people, where they're inspired by measurable features of humans, computers, things and their context. The key word there is measure. Now you go measuring, many of you do. You travel into the world and you take from the world with cameras, instruments, and you measure from those contexts and you elicit the data. You often take it back to the studio, back to the lab, and you're designing it from, not with. Because design with data, when systems are designed by people, where they take into account the flows of data through systems and the need to make data manifest to reduce its obfuscation and improve trust. And here really we're talking about the fact that much data travels in real time. Designing from data doesn't infer real time. It's an instrumental approach, going out, measuring and bringing it back. With data suggests that we're beginning to take account for the flows. And it means that the flows then begin to have implications, and how we reduce the obfuscation, improve trust, is about what we do in design informatics. Again, studying the flow of data within systems. And the last one, I think, is the most provocative, but the most important for the next decade, which is design by data. And here you'll notice in the first moment that when systems are designed by other systems. The previous classifications dealt with design by people. Design by data, when systems are designed by other systems, largely autonomously, where new products and services can be synthesized via the data-intensive analysis of existing combinations of humans, computers, things, and contexts. And you'll see that actually humans, computers, things, and contexts are moved to the back, when actually we're inferring that the designing by data gives data itself performativity and agency. And this agency allows it. So if we talk about really designing by data, well, software will be designed by data, no longer humans. Some of the software that you'll be using in the next 5 years, I guarantee will be designed by AI systems, not by humans. You can argue that it's derived from human starting points, business projects, plans, but the AI has agency alongside and possibly more than you as a human being. So let's dive in a little bit further. So design from data. Now, classically, what I should do here is just tell you about questionnaires, interviews, ways that we go into the world with cameras. Perhaps you use cultural probes, design probes by Gaver, and you gather up data with instruments and you measure it and you bring it back to the lab for analysis. Well, we do a little bit of that, but really I want you to take to the more challenging spaces. So when systems are designed by people, when they are inspired by measurable features of humans, computers, things, and their contexts. But I'll tell you about how we do it because we're curious. And what we do is develop technology probes. Technology probes is an idea that you can use software or hardware or a combination, put them into the world, and from it you begin then to elicit data. It's definitely a from approach. But I'll just take you through one of them, which has been very successful. Here, this is the PwC smart contract continuum. I won't dwell on it. In fact, they took it down, but it talks about a period before 2017 when the Bitcoin spike came up, which talked about how smart contracts using Ethereum, using a blockchain backend that allows a smart contract to be developed, piece of code, and you can see the third one in. For example, a landlord has applied a smart contract to a lock on a door on one of their flats. So a landlord remotely locks non-paying tenant out of the apartment. Pretty sinister if you ask me, but the idea being there that you use smart contracts to perform the flow and manage the flow of data and in the end value across these informatics. And they move all the way along to the right, distributed autonomous societies. What might it be like to extend these digital contracts across society so that cars get their own Bitcoin wallets? I have a wallet, not necessarily Bitcoin, but maybe it allows me to have a passport, and I could begin to talk about starting up my own society. And I don't need the Bank of England to confirm that. So we began to play with that in 2016, a year before the big spike, by distributing Bitcoin in the streets of Amsterdam. So we used a software package called Electrum, which was a very simple, crude, smart contracting software, and we could literally scatter Bitcoin in the streets. So in other words, what we're doing here is adding a Bitcoin wallet to GPS coordinates. So here you can see the red spots and the blue spots and the black spots. If I walk into a black spot, and you can see me trying to use it in a browser, it worked better on the phone, of course, in the street. My phone would be given a Bitcoin wallet, and if my GPS coordinates hit those black dots at the bottom, I would be given chunks of Bitcoin, literally transferred from one wallet into another. If, however, I entered the zones, the green zones pay out Bitcoin if I stay there for a period of time. The red zones deduct money. So the aim was to get back to the office without having lost too much money. I think the year later, we experienced Pokemon Go, so it was very much part of that culture. This is me in Tel Aviv walking down a daisy, I'm going to turn down the street. This is then we flipped it to Ethereum, and here you can see I've got a balance at the bottom. I'm being fined for staying in the blue zone. As I head down the street, I'll try and get some money back by moving into the green zones. So we're curious about this because it does allow us to acknowledge that there's a more than human opportunity. By giving GPS coordinates and giving it a wallet, it means that a lamppost can be a member of society. It can choose to give me money or take money away from me. It's a very basic power play. If you want to empower people in a crude sense, just give people money and you will see what they do with it. Isn't the right thing to do? On the other hand, universal basic income talks about empowering people in a similar way. So here I've hit another green thing. As I head down, I'll hit more credit zones, as we call them, and you'll see my credit fly through the roof. No, you won't, because I stopped the video, but you get the point. So we give this to people. We gave it to 3 urban planners in Amsterdam using the Electrum version, and they came up with this idea. So what they proposed was, if you could tokenize land and you could tokenize spaces and places, then let's put 200,000 euros from the Amsterdam City Council that would have gone into capital projects for schools, recycling centres. Let's move it into a digital currency and give it to every resident. And here what's happening is participatory budgeting. So they flipped the imaginary around the software. This is a person moving across the streets as they've been given some of this cryptocurrency. So it means that they can actually literally move money in the local government bank accounts. They're moving money. They can't take money out of this cryptocurrency and spend it on bread and beer. They can only move money according to the geofences in the street. So in the context of participatory budgeting, they're literally moving money and accounts from the council, which means it's participatory budgeting. They can also click on the blue piggy bank, the Bitcoin piggy bank, and they can instantiate their own zone and ask for funds to be spent on the bicycle stands. If someone else in the neighborhood likes that idea, they will move their money into the bicycle stands. So you suddenly begin to turn the economic power of control in a local government context into the hands of the people, because you can begin to you can tokenize euros. Here again, we do it with Tesco Bank. We work with Tesco Bank, who have a headquarters in Edinburgh. Here, this little team, there's 3 of them, you can't see the other guy at the moment, they wanted to reimagine currencies around cinema tickets. So here, and I might have to scoot past this a bit, here they're going to enter a cinema. It's all in their minds, completely virtual architecture, but they're entering a cinema according to the business model. And I'm curious about whether you understand that architectures are not physical, they're just business models. Here, the Tesco Bank clearly understand that a cinema is just a business model. What they've done is they've gone to the cinema. This guy's traveling down the street, and you can just see him over on the right here. He's going to take a ticket. That bubble went because those 2 took a ticket into the cinema. This guy's going to take a ticket. Now, critically, the other 2 want to go and see the trailers, and this guy doesn't. So he's going to take his ticket, but he's not going to see the trailers. Meanwhile, Laura is going to enter the trailers now, and she's going to tweet from inside the cinema. So we're watching the trailers in the business model. This is all architects do, is build business models. They just manifest them. She's tweeting, and she's going to get paid back for tweeting. In a moment, she's going to meet the other chap. I'll just skate forward. And they're going to enter. Now they're actually entering the main cinema, the main feature. And believe it or not, they're now watching the main feature economically. But what's going to happen is Laura's going to leave the main feature. So they've entered the main feature here, the big blue area, and then she's going to leave. She's going to take her Coke carton with her, and we're going to pay her back. He's not, but he's going to write a review at the end of the show, and he's going to be paid back. So this team are using space and place and a digital currency to rewire the economic architectures as we know them. So suddenly we can talk about cinema being something completely differently. So why this is designed from data? Well, we use exactly the same methods. This is over in, where was this? This was Brussels. We took part in a blockchain workshop, which eventually asked us to interrogate decentralizing things such as the national grid. Highly centralized process. As you know, energy is managed and moved around the UK, but what might it be like to deal with a decentralized model? Well, what we did, we developed 3 prototype hairdryers, and these hairdryers then become technology probes which we give to people. And by listening and watching how they design with these or live with them, we design from their data and the data they tell us. I just briefly scamper through what these do. The first one places smart contracts in the hand of the user. So here, Sean is going to get up. He's a student, gets up at 4 in the morning when energy is super cheap in the UK. And he's going to buy energy and put it literally onto a virtual account and buy it through the hairdryer. So on a Friday night, he's then going to sell that energy back in a local energy network, and people who use it he will then get profit from selling that energy at a higher price. I'm going to scamper through these. The second one suggests that he doesn't want to get up at 4 o'clock in the morning. So in this, he's got a bot which is coded onto the hairdryer, and he's asked for energy from the grid, the decentralized grid. It's now trading and looking for the right type of energy. Maybe he wants green energy, maybe he wants cheap energy, whatever his values are. It will then tell him when it's found it, and in this instance it took about 20 seconds. It might take 2 minutes, but he's getting the bot to do the work. You don't ask the question when you turn your plug sockets on how much it's costing. You should do, because it's just a market. There's an energy market, and you should be able to ask the socket to get the right price. In the last one, we said we don't actually trust any humans. We don't trust any of you, really, we don't, to manage these decisions, because you always want nice hair. So in this instance, we've taken all the buttons away, and Sean's having to wait a very, very long time because the instrument will only tell him when he can blow dry his hair according to the energy in the local area. And it isn't in the local area's interest to burn that energy. So we wait, and we wait, and we wait, and eventually the hairdryer turns on. Now what we've done is, in the design from data context, is we then give these things to people and listen to what they think of them. So in this instance, we've got 3 actors who are primed about the technology, but they're literally improvising about the use of the technology. And this woman has entered these people's home, she's plugged in a hairdryer, and she's making money from their energy. And they're a little bit offended to begin with, because she has to explain that she's actually taking money and making money from their energy. And they don't understand. But this is how we design from, because these artifacts enter the world and we understand what it means for these people. Now, designing with data, closer to where I think you and I should be working when systems are designed by people, still a human project, but they take into account the flows of data. We understand the flow in real time, and we need to make and explore them being manifest and reducing obfuscation. This is a good IoT case, really, designing with data, because we know all IoT is streamed in real time. So in this instance, in the old days, I used to go to the supermarket, and if I wanted a cup of coffee, I would have to go to completely separate aisles to build my coffee. And the value proposition, if you think about it, how does anyone know Chris wants coffee? Well, it doesn't happen at the till because they don't know what's in my basket. It actually needs to start happening at home. So more recently, you'll know that Google bought Nest 4 or 5 years ago, and they're beginning to use technology to place the value proposition inside the home by scanning energy use to understand what you need. So for example, if I look at the 3 kilowatt kettle, I know that Chris is boiling boiling the cup. And the question is he going to boil for pasta or making it a cup of tea? If the fridge opens and there's an energy trace on the wire, then maybe he's making coffee. And from that, then I can then push adverts. So we worked with Warwick in particular and wired up my house. We bought some products from the shops, but we also added a device onto my electrical meter to see how much energy I was using. And it worked really well. We sent the data back to Cambridge for analysis. And at this moment, the team were terribly excited because they identified that in my house, there was a dinner party going on. The humidity, the heat had all gone up. And actually, that peak on the top chart there was when really Haagen-Dazs could have come round and sold me ice cream to lower the temperature of the party. So you see that data is being used, but it wasn't very well exposed. So if we were designing with data, that was very good for the marketing teams, but my team wanted to understand the obfuscation. So we then went down a different path, designing with data, looking at how I use these particular scales to monitor my weight, and you can see it fluctuates between 70 and 72 kilograms. And I have a register for my partner, my daughter, and my son. But I also have unknown measures. I have people, believe it or not, going into my bathroom, apparently recording things on there which the machine doesn't recognize. And here you can see 22.6 kilos was registered at 20 minutes to 20 minutes to 11 o'clock on the 14th of December, way back in 2013. You might figure out what it is. We guessed in the end, of course, doing a bit of machine learning with our brains, not computers, that it's probably an EasyJet luggage. So in December, we're probably about to fly away to somewhere for the Christmas, and we had a baggage that was too high. Now, all I've done there is elicited something from the data in real time. Now, we wanted to keep pursuing this because sometimes things are hidden. Behind that door is my toilet. So we began to then install things. So we installed an Internet of Things toilet roll reader, and on the back plate there's a hole because there's an infrared infrared measurement device measuring the width of the toilet roll. And that means I've got a live trace of the toilet roll in my downstairs loo. And I'm running it live, and I'll tweet it later to you. But it does give me a completely different relationship with live data. So can you, with your machine learning eyes, spot a poo or a wee? Well, you should be able to, because the large drops in data are when a significant amount of toilet roll is used. If there isn't much toilet roll used, then it doesn't drop so much, but I'll give you a hand. And it's a bit of fun, but it's been proven very, very useful as a case study to understand that designing with data brings with it ethical, social, and economic implications. I could set up the code and a smart contract to simply order the toilet roll because I know, and it knows, and the world knows, the internet knows when I'm running low. I've also had people refuse to go to the toilet downstairs simply because I have to declare ethically that it's on the internet. So design with data does involve entirely different design possibilities. I can no longer just shut off the data, put it in a box, and design from it. Now, the last one I think is the most exciting. This is when we're acknowledging that humans are being flattened in an ontological sense, that the hierarchy flattens, that humans, computers, things, and contexts all become flattened, and that actually the systems themselves will design propositions or products. And it really goes back to even 2014, when by 2017, even Gartner thought that a significant disruptive digital business will be launched not by a human, but conceived by a computer algorithm. So we already starting to see some of this, and we know that algorithms are disrupting many parts of our democracy and our market spaces. To put it into context, what we began to do then is argue by reading around object-oriented ontologies that in some ways things can have agency. We'd already experimented with this by giving them Bitcoin wallets. But in some ways, designers are always very good at making things do more than the things that the original designers planned for. The argument in this particular case was that we shouldn't put humans at the top of the design tree. Architects are terrible at this. You're still being sold ideas that you can be the superstar architect, and trust me, you won't compete with the AI, because very simply, you've got designers who think they're at the top. For a long time, we've been working with the crowd as a source of co-creation, but in the end, if you look around you, All of your rooms, I guarantee there are more things around you than designers as humans. And if we can get data from those things, then those things will be the things that design the next set of products and services. So for an example, 854 people work together across the web to invent this groovy thing. Great. How many people and how many four-way plugs are there in Europe now? And if the data within clouds began to machine how humans were using those four ways, think how many more design solutions would emerge if we gave the power to four ways and algorithms to design new products. I guarantee it will be more than 854. So we began to use that concept and we started to work with metaphors such as a fork. So let's take this fork. The fork doesn't know what it is. The fork has no clue what its job is. It sits in a tray, a cutlery tray, a drawer, and it's incredibly dark. All it knows is twice a day it comes out. Often it comes out in the evenings, and it comes out with two friends who are completely different. One is very slender and sharp. The other one is quite curvaceous and rather lumpy at the end. Slowly, after watching itself and understanding what it interacts with, it begins to figure out that maybe it thinks it's a fork. I mean, maybe it does. It doesn't know, because in a pluralist society, we shouldn't be binary about this, because actually someone in the same family has been starting to use the fork for different reasons. Someone started to use this fork to open paint pots. Suddenly the data set, the digital twin of that fork, suddenly begins to think, maybe I'm not a fork all the time. Maybe I'm a screwdriver. Who knows? Who knows what the digital twin thinks, because it will be in a cloud and it will be offering propositions to us and designing with us alongside other things. So we've done a whole bunch of things. We started to use machine learning to look at image searches. So we used visual analysis, downloaded as many pictures of forks as we could through the internet, and discovered a whole bunch of instances of what they could be. And we began to use deviation. When is the picture of a fork in Google Images, millions of images, not doing the thing that we expected it originally to do? When is hybridization? So when can we, and we wrote algorithms to spot hybridization in the imagery. In other words, when is an object used for a different purpose than originally intended? However, in order to perform additional functions, the object, it becomes modified. And then finally, partial hybridization, when objects adopt some of the original properties of another object, and then somehow its usage is still unchanged. So you begin to see that these things are no longer fixed in the data sets, in the clouds. A fork is not just a fork because a human gives it a definition. If we open this up to machine learning and AI, we begin to find that in the latent space, suddenly in a data set, things can become very, very different things. And the things will own those propositions, not humans. We also looked at repurposing, when those things reused, and it throwed up a whole bunch of different instances. So it was very successful. What we did in the practice, though, because we wanted to get back to designing, is then began to think about how we do involve, because it's a bit more mundane, it's less AI. We use these autographers. Autographers are little cameras which you can program to take pictures all of the time. Ethnographers and anthropologists use them, and they tend to stick them on humans with lanyards around their neck. But we chose to start putting them on objects, because in a flat ontology, we have to accept that the kettle has as much right to see the world as the human. So we put one on a kettle and a cup on the fridge, and we gave one to a human. And we got another huge data set. What was really interesting, though, is as we also added some instrumentation. So these little Arduinos sit inside the kettles, and they give us a data stream, also a live stream from the fridge, from the kettle, as well as the picture stream, because the picture stream gives us a qualitative view. And this is the final slide, actually. This is what we got. And I'm going to argue to you that the instruments allows us to see the world beyond the human. What we have here is a little love affair, a love triangle. We found two humans in a family, and they don't know that each of them is having a love affair. And it was the objects that began to help us see this. So there was something secret, something obfuscated, but it turned out that through the watching, through the instruments and the data streams that we received, that both of the two individuals have a love affair with a cup. They didn't know that they had a favourite cup, but it turns out that both of them love a particular cup. And they didn't know. It just happened to be that they both used one cup excessively, but they didn't tell each other. And we wouldn't have seen that unless we'd instrumented the objects and began tracing their activities. So we think there is a case for designing by data. And here's the three cases: from, with, and by. And I just encourage you all as designers, creators, to think about how you want to add a lexicon toward data as you enter design computation. Thank you very much. I'll stop there and exit the slides.